All righty. Hello, everyone. Good afternoon now. Thank you for everyone joining us today for our Big Valley Integrated Hydrologic Model Subcommittee meeting. For those of you on the phone, let's just go ahead and do just a real quick round of introductions. Marina Delajanis, Deputy Water Resources Director and lead of the GSPAC. I'm going to pass it over to Will.
Hello, everybody. My name is William Fox, and I'm also with Lake County Watershed Protection District, serving as a program coordinator, and I'm out doing a lot of the monitoring for Big Valley and across the Lake County basins. I'll pass it over to Maritza now.
Hi, I'm Maritza Flores. I'm a associate facilitator with Stantec supporting Lake County. I'll pass it over to Christy.
Hey, Maritza. Christy Clark. I work with Maritza. Eddie?
Eddie Teasdale, Ludorf and Subcommittee Consulting Engineers, working with Stantec to support the county on developing the GSP. And then I've got two folks on the line from Ludorf, Nick Newcomb, who I think you've all met before for some previous meetings, and also Kev Esposito, who's been supporting Nick on some of the modeling efforts. So I think with that, I don't know, Ibrahim, you want to do a quick intro and then pass it off to the ad hoc folks?
Yeah, this is Ibrahim Kadam with Stantec, helping Eddie here on developing the plan.
Peter, you're on mute, but we all know who you are. So
yeah. Yes, for better or for worse.
No, I didn't say anything. I just said Peter.
I am here.
And Bethany, really quick, can I confirm that your number is the 805 number ending in 3417? Is that correct?
Yep.
Okay. I'll change that. So we have two of you. You're doubled up today.
So Bethany, Sarah, and is that it for the group?
Yep. Sarah Ryan, Big Valley Band of Pomonians.
Okay.
And then we do have our water resources engineer, Yulia Osatrova, who is hopping on right now. So if friends see a new name on the screen. Did everyone get a chance to introduce themselves?
I think so. Yeah.
Awesome. I'm going to go ahead and pass it over to Eddie.
Great. Well, thanks everyone, and thanks for kind of meeting. It's been a kind of a scramble the last couple of weeks. So we've got about an hour. We're going to try something a little different this time. We're going to sort of maybe spend about 20-25 minutes kind of walking through kind of some items that I heard at the last GSPAC meeting that folks had some questions, concerns about. So we're going to kind of address those. And then really we want to open it up to sort of to listen to some of your concerns, questions. I know the GSP has been out for a couple of weeks. I know comments are due tomorrow. There's a TM in there that sort of details some of the modeling efforts. So again, we want to spend a little more time kind of listening to some of your concerns and perhaps look at ways that we can sort of either address them now or look at ways to kind of figure out how we can address them sort of in the not too distant future. So Nick is going to load up the presentation, hopefully. And again, he's going to kind of lead the discussion for, no more than hopefully 30 minutes. And then really, we want to kind of really open it up for questions. But as always, we're, if folks see things during the presentation, speak up, let's have a conversation about it. But again, we have about an hour and we want to get through as much as this as we can. So hopefully that sounds okay. Nick, do you want to maybe load up the second slide?
Yeah.
Okay. And I can touch on just the first two items really quickly. We had sort of this group met in September. We've had some discussions with the GSPAC, subsequent discussions with the GSPAC that weren't as model intensive with the GSPAC, but we try to get that information out there. And then at the November GSPAC meeting was really where we dove into the water budgets. So again, a lot of the water budget information, all of the water budget information is coming out of the model. And so that was it was a pretty intense event a couple Fridays back. But anyway, and what some of the questions that came out of that GSPAC meeting in November has kind of prompted sort of a couple of items we wanted to touch on today, primarily frost protection, talking a little bit about the stream depletion. There's been some questions about, how are we looking at sort of the future demand, be it changes in agriculture. We've had questions about, the future of cannabis. So we've want to talk a little bit about that as we kind of, touch on these items today. And then again, ultimately, our goal is to sort of open it up for discussion and for you all to provide comments, feedback, concerns. And so I think with that, Nick, it's all you, man.
Yeah. And so this should be relatively short. And I think we want to mainly leave some time at the end for discussion and comments and kind of future directions and stuff. So the first thing I wanted to touch on was the frost protection element that we didn't get to when we did the presentation back in September, describing kind of the model development. So yeah, with frost protection can be a pretty significant demand for groundwater pumping. That's not like a evapotranspiration demand, so it's a kind of an added demand before the irrigation season. Our understanding is that the applied water is happening to vineyards and orchards to avoid damage to the buds after bud break. And it's applied when the temperatures are approaching, freezing. And a lot of kind of the background information we got from this paper that Peter Winter put together. So for our frost protection period, we assume started in mid to late March and goes through May. And again, it's applied to vineyards, which have about 4,300 acres in the Big Valley Basin, and then pear orchards, which are about 1,500 acres. And so this is kind of focusing on the historical period. We also applied the frost protection in the future as well, in our future projections. And so again, the frost protection, we assume occurs when the minimum temperature is approaching freezing. So basically we set a threshold of 32 degrees Fahrenheit. And so when we got those data, got basically minimum temperature data from the Western Weather Station at Kelseyville, and those data were available from 2010 to 2019. And then we filled in the gaps from 84 to 2009, which was kind of our historical period, with data from the PRISM Climate Group up in Oregon. And so based on that, this chart on the right shows the number of days where there would be irrigation for frost protection in each year. You can see it's pretty variable depending on the year type, if it's a pretty cold spring versus a pretty warm spring. And then for how much water, we assume that every day that the temperature dropped below, we're at or below 32 degrees Fahrenheit, we assume there'd be about 4 hours of irrigation per night and an application rate of 0.11 acre inches per hour, which I think is about 50 gallons per minute per acre. And those, we kind of looked at a couple of different sources, and that seemed to be a pretty consistent application rate. So again, yeah, the amount of water applied for frost protection is pretty variable. It can change a lot from year to year. And so this top graph on the upper right shows the irrigation for or the applied water for frost protection versus irrigation for crop demand. And so you can see that on the bottom right here, you can see that it can be a pretty substantial kind of relative fraction of the total applied water, ranging from, if it doesn't happen, to 0 to more than 30% of the total applied water, based on what we were able to pull together. So that kind of covers the frost protection. We can answer maybe just save the questions for the end, because we'll get through all this pretty quickly and hopefully have a little bit more of a discussion. The next thing I wanted to touch on was the stream depletion. And before kind of getting into that, I just wanted to go over some background information regarding stream aquifer interaction. And so there's basically kind of 4 types of interaction between a stream and aquifer. You have a case where you have a gaining stream where you have flow of groundwater to the surface water system, and that's on the top little figure there. You have a losing stream where you have water going from the stream into the aquifer system. You have one type of disconnected stream where you have flow in the stream, and that water is basically percolating out of the stream and going to the water table, but they're disconnected hydraulically. And then this last case, you have a disconnected stream, but there's no water in the stream. And so kind of based on what we've seen at different times of year in different locations, we might have any of these conditions happening. And it's kind of important to think about that it's not, just one case, but things can change spatially and temporally. And then we talk about stream leakage, which is that net flow between the surface water and the groundwater, and that can happen in either direction, whether it's gaining or losing or disconnected. And then just a quick background on stream depletion. And this is all taken, I might back up, from this Barlow and Leak paper that the USGS put together a few years ago. And it's really helpful and really approachable. If you want more information, it gets into kind of the details in a way that's understandable. So yeah, looking at stream depletion, just in a pretty simplified case, you have, in this case, a gaining stream. And so you see the flow lines going towards the stream and you don't have a well. When you start pumping a well, a lot of the water is initially going to come out of groundwater storage. As you continue pumping the well, in this case, you're going to start intercepting water that would ordinarily go into the stream. So it's less water coming out of storage, and that pumping is going to basically hit this nearest boundary condition, which is the stream. And then as you continue pumping, this is like kind of an extreme case where you actually reverse the gradient and your stream goes from gaining to losing. You can also, this is just one example, you can also have a losing stream and you pump your well. Initially that water is going to come out of storage, and then eventually you're going to induce more stream loss. And so you're going to have, as you go downstream, less and less flow. So the way we looked at stream depletion, there's the GSP regulations that require us to identify interconnected surface water systems and quantify the timing of depletion in those systems. The way we did that, and it's also kind of the way that's outlined in that Barlow and Leak paper, is you'll have the calibrated model, and then you'll take out groundwater pumping from that model, and then you try and basically recreate this natural system. And when you look at the difference between the stream flow in this kind of natural pristine condition in your calibrated model, that's going to be a quantification of the stream depletion. And so here, kind of the assumptions, we removed the groundwater pumping for agricultural irrigation and landscape watering. We left in the pumping for indoor water use. That's going to be like drinking water and kind of domestic uses, just because it's like that's pretty hard demand. And people need water, and that's important. And so we assumed that agricultural and landscape water demand is met only through precipitation and surface water. So when we go back to like this kind of conceptualization of the landscape processes, we're basically just cutting out this well term, and everything else is still happening here. And so yeah, the land use and the surface water diversions do not occur or do not change. And again, we're looking at the historical period from 1984 through 2019. So looking at the results, so these are just the raw stream flows. We have Kelsey Creek on the upper left. And I think, so you can see during these low flow periods, this is a logarithmic scale on the y-axis. But during the high flows, like the relative difference in stream flow isn't that great just because you have a lot of flow. But during these low flow periods, in this first year here, you can see a condition where there's maybe 2 CFS in the synthetic run, and the stream is dry in the calibrated, like actual conditions. But then during these kind of drought periods, in both cases, you have, basically the stream going dry. So it kind of suggests that climate is a pretty big driver in all this. Obviously, pumping is maybe exacerbating these conditions, but climate is kind of driving the whole situation to a pretty large extent. On the bottom here, you see just the monthly stream flow in the baseline model versus this synthetic model. You can see kind of like these relative impacts. And again, it's a log scale, so it's difficult to see, but the relative impacts are going to be the biggest in during these low flow periods, July, August, September. Over here on the right are the results from Adobe Creek. In this case, regardless of whether there is pumping or there isn't pumping, you see a lot of these low flow periods. There's no flow in Adobe Creek. And you can see on that bottom chart there. So these are the mean monthly flows over that period. Again, in July, August, September, there's a lot of cases where you have pretty low flows or no flow occurring. So I think kind of one of the main key things we want to take away from this analysis is how groundwater pumping is going to influence hitch spawning and habitat in Kelsey Creek and Adobe Creek. So in these charts, we're just focusing on the flows in April. The hitch spawning generally, I think, occurs from March through May. And so we took kind of the middle of that to see what the flows would look like with groundwater pumping or without groundwater pumping during those periods. And kind of the first thing to take away is that this black line on the bottom is the reduction in stream flow, the absolute reduction. And so in Kelsey Creek, we're looking, pretty consistently at about 2 to 3 CFS. In Adobe Creek, it's a little bit more variable, maybe from 1.5 to 3.5 CFS total stream depletion. And these charts on the top show the actual stream flows in April. And you can see that there's not a huge difference in Kelsey Creek, say. And this kind of orange line on the bottom is showing kind of the percent reduction in stream flow in April. So it's really, it's not a huge difference, kind of generally less than about 5%, but can get up to about 20% when you have low flows in the stream up here. So the relative impacts are going to be the biggest when you have the lowest flows. Over in Adobe Creek, these flows get a lot smaller in the spring. And so even though you're only seeing, maybe 2 to 3 CFS of stream depletion, the relative impacts can be pretty great. And in this case, like kind of approaching 80 or 90% of the stream, the flow in the stream there. And so these locations were taken kind of at the tail end of each of these streams too, kind of near Clear Lake. Yeah, and so, we're not really in the position, I think, to make a determination about, what kind of impacts that would have on habitat. But hopefully that can help, this modeling can kind of help inform that to a certain extent. So the last thing I want to touch on is looking at kind of uncertainty in future demand. So the demand in the future is going to be determined, I think, mostly by water supply, climate, and land use. In the case of climate uncertainty, we included that in our modeling for the GSP. We had a wet and moderate warming climate future that we pulled from a global circulation model, and then a dry and extreme warming scenario. So, we're kind of able to bookend those two climate extremes. But in terms of land use, it's a little bit more difficult to predict. Based on our conversations we had with the Farm Bureau, it doesn't seem like vineyards and orchards are anticipated, the acreage is anticipated to increase in the future, more likely to kind of stay the same or decline. But there is an emerging market for commercial cannabis, and that's shown over here on the map on the right. And you can see the different proposed and pending cultivation permits for cannabis, and it's pretty substantial in the subbasin, and it could be a pretty big demand on the water supply. And so there's that, and then there could be other markets that we're not even aware of. We're looking forward, and so it's hard to predict what's going to happen. So we wanted to be able to evaluate what conditions in the subbasin or in the basin would look like, if we were to see a substantial demand increase going forward. And so here's kind of the methodology we took. We were focused on agricultural pumping. And basically on this chart on the upper left, the orange is going to be the existing agricultural pumping, and the first bar is going to be the historical. And then we took this, the scenario C, which is the dry and extreme warming scenario where the demand is going to be the highest because there's less precipitation and the temperatures are hotter. And what we did is took that baseline amount and then we added 10% increase in agricultural pumping, 20%, 45%, and a 90% increase. And we basically wanted to see what that would do to the groundwater levels at our representative monitoring sites in the basin. And so again, I think it's key to note that even though we added this green increase in ag pumping, the existing agricultural pumping also goes up a little bit. And that's just due to these kind of different dynamics that are being simulated. If you pump more water, the water table is going to decline and you're going to get less uptake for crops from the crop roots. And so you're going to have to make up that difference in demand by more groundwater pumping, basically. Another key thing is when we added this extra pumping, we didn't kind of return that water as deep percolation. So again, that's like pretty conservative. The water is not being applied and some of it's going to inefficiently percolate. Like this water is being taken out of the model, which is a pretty conservative assumption. So again, this is just kind of a schematic looking at how we did that. We have this baseline agricultural pumping for this future scenario that's based on the crop demand and the frost protection demand. And then we add this artificial increase in demand. So we add new pumping into the model. We just added, I think, an equal number of agricultural wells and then just added in this pumping demand to it. And then we run the model and assess kind of the differences in the water levels between the baseline scenario C model and then each one of these pumping increase scenarios. And so here's kind of how we looked at that. These two charts on the left are showing, I think, this northern RMS well. And so here on the top graph is the baseline scenario C water levels. And then in this case, on the bottom, we're looking at the scenario C with a 90% increase in pumping. And so the best way to look at this, we thought, is to actually look at the differences in water levels instead of the absolutes to just kind of tease out what kind of impacts we might anticipate. And so kind of focusing in on just a handful of these RMS sites, and I have the other ones if we need them. But so looking at this northern site, under a 10% increase, we might be looking at a decline in relative groundwater levels by about like 3 feet. 20%, it's maybe like 5 to 7 feet. 45% increase, we start seeing a much bigger impact, maybe looking at about 12 feet during the irrigation season, or 15 feet during the irrigation season. In the spring water levels, maybe more about 3 to 5 feet water level difference. And then with a 90% increase, we see more than a 10-foot relative groundwater level decline in the spring and up to a 30-foot water level decline in the fall water levels. And then focusing on this one, so the impacts aren't necessarily equal everywhere. We're looking at this East Central representative monitoring site with the 10% increase. Again, we're looking at maybe 1 foot or less of a water level change, and 20%, maybe like 1.5 feet, 45% increase, and it's like 5 feet, and then a 90% increase, and we're looking at maybe a 10-foot maximum water level change or maximum water level difference between the baseline. And then just here's another example. Again, this is a case where you see some bigger impacts as you increase that pumping increase to about 90%. And I'm happy to kind of keep going through those. There's the 3 other sites or talk more about it if we need to. But yeah, I think at this point, we can probably switch gears and just open it up for discussion and answer any questions or take any comments or suggestions too.
So earlier around slide 5, Sarah made a comment on the chat. She asked if you could please provide the sources for the application rate.
I think the application rate might have been included in this report, and then I can dig up. There was another reference we had for irrigation for frost protection and when we worked out, they had the 0.11 feet per acre per hour. And then I think in this report, there was the 50 gallons per minute per acre. And if you do the conversion, those come up really close to each other. And I can pull those two references and send them over if that's helpful. I don't have them off the top of my head.
Thanks. Brenda has a question. Brenda?
Yeah, thank you. So sorry, Nick, I was in another meeting, so I came here a few minutes late. So I just want to confirm, when you're running or when you're turning off groundwater pumping in the model for that period of spawning in April, are you just using frost protection, or are you using irrigation plus frost protection, or some combination of the two? I didn't hear how that got shaken out.
Sure. Let me get down to that. So we're turning off any groundwater pumping for agriculture or landscaping total. So no frost protection and no irrigation. And it's actually, we turn it off for the whole year. So that everyone's basically either applying surface water from diversions or relying on precipitation, basically.
And what's the timing on when you turn on, like in the model, what's the timing for when irrigation pumping begins in the year?
So generally, like in the baseline calibrated model, it's whenever there's a demand for it. So
okay.
Yeah.
Okay. Thank you.
Bethany had a question. Bethany?
Yeah, so I'll actually still on this slide. So I'm just wondering why, I don't understand the decision not to turn off also the domestic water use, groundwater use for looking at depletions, because the GSP doesn't distinguish, it talks about groundwater use impact on depletions, not not just agriculture. So explain that.
Sure. Yeah, that's a good question. And it's, well, I think first off, I think you're right. We probably should have looked at both. But the M&I pumping and the domestic indoor pumping is really small, like less than 1,000 acre feet compared to for agriculture and outdoor watering. Is more on the order of like 10,000 acre feet. And then also, I mean, I think we need to recognize like the human right to water too. Like people need water. And so it's kind of just an assumption we made that these people are going to need to pump regardless, because, you know, you need water to drink and for other domestic uses. But that is a good question. But I don't think that, you know, just based on the relative amount of pumping, I don't think it's going to change the results very significantly.
Okay. And so the result is that there's up to 90% depletion of total flow in Adobe Creek in April. And that's when the hits are spawning. So to me, that sounds like indication that there is an undesirable result occurring to the hitch beneficial use of Adobe Creek. And so it's this is like new information that I'm seeing right now. And so it's interesting to me that basically the GSP is kind of saying, well, there are no undesirable results for depletions. So we're just going to pick the lowest measured ever spring elevation because there is no problem. And to me, that says, oh, it probably is a problem. So.
Yeah, and again, it's kind of everything's relative. You know, you're talking about 3 CFS of flow. You know, maybe being depleted to like 0.5 CFS of flow, and so that's kind of why I wanted to couch this in terms of, you know, we're not really equipped to determine if that's an undesirable result because it's you know, more for a fisheries biologist. But you know, I think it's important to ask whether at 3 CFS is enough to sustain spawning to begin with. And if so, you know, I think, and Eddie had presented some other stuff, I think back in November regarding kind of some options for mitigation too. But I think it's definitely something that it needs to be kind of looked into a little bit more going forward. Kind of what kind of impacts they are and how that might affect you know, the spawning and the fish population.
Yeah, because we're not even looking at May, and May is also a spawning time. So anyway, yeah, thank you.
Sarah, you have a question?
Yeah, Nick, did you see the technical memorandum that the tribe submitted from Flow West that was from December 2020 that gives the reaches that are, you know, based on our pressure transducer data and the understanding that we have of the flow of Adobe in relation to Kelsey based on 10 years of corresponding data. But it showed multiple locations where the hitch weren't able to pass because the flow was so low. And I'm not sure why that wasn't factored into here when that was provided really early on, because you're saying that we don't know if, you know, what the flow is going to be needed. We're not fisheries biologists. So how did that data factor into, you know, I mean, given that you're using a report written in September 2021 to give you what the application rates are for frost protection with no meters, no data on that, but we're submitting data from more than a year ago, or almost a year ago. So how did that factor in?
Yeah, so I am familiar with the report, and we actually use that data. I think you guys recreated the flow in Adobe Creek. You did like a hydrograph reconstruction for Adobe Creek based on Kelsey Creek. And then we actually compared our model to that as well. Again, so I'm not a fisheries biologist, and I'm not really in the position to review that report in that context. And so with that in mind is why, you know, I didn't make a determination regarding whether that's substantial difference. And then it's also important to recognize the uncertainty. You know, these are model results. These aren't, you know, actual results. And so, you know, in the model, the flows during a dry period or a wet period might be plus or minus a certain amount within the range of uncertainty. And so I don't think it's that important to focus on like these absolute numbers during specific years, but to try and it's more to just kind of give us a sense of what's going on. And I hope that's kind of helps answer the question.
Yulia, you have a question?
Yes, I apologize. I did join later, so I might have missed the assumptions that were presented, and I couldn't find any attachments to the meeting schedule, so I don't have PDFs of this slide, so I cannot go back and forth, and I can, so I'm a little lost. Would be great if they would be sent. I have a question for the consumption categories that were in the model.
This one?
Yeah, that'd be great. Yeah. So for indoor domestic, how much race of population did you put into the model? And also, how many years? It's to 2060, right? Because later, I believe it showed the level falling, and I think the last year was 2060.
Sure. Yeah. It's 2070.
Okay. I'm sorry. So I missed that. But how much of the population increase did you put into the model? And also, how much increase of the consumption rate by the residents. We live in California, and we do consume water much more, much different than, I don't know, African countries. So
Sure. Do you have more?
So far no. So far I'm good. I understood everything, but it would be great to have slides, you know.
Yeah, and some of this was in an earlier presentation we did
Okay.
back in September, but I'm happy to go over that indoor usage again. So basically there's areas within the sub-basin that where there's metered pumping that we're able to get from the State Water Resources Control Board. And so in those cases, we plugged in that amount of pumping, and that's actually we kind of broadly categorize it as municipal, but it also encompasses some of these smaller public water systems. In the cases where we didn't have that information, so that's going to be some of these smaller public water supply systems that don't necessarily report or haven't reported to the state. We assume that they were reliant on groundwater. And then the USGS has a pretty good report that has an estimate of the per capita indoor water usage. And those are regional estimates. And so we're able to get that estimate for California. And I want to say off the top of my head, it was like 80 to 100 gallons per person per day. And then we were able to estimate the population that's outside of these public water system areas using the census data. So there's different census, I think it's tracts or blocks that get down to a pretty fine resolution. And so we took, I think, the 1990 census and the 2010 census, and we're able to get estimates of population that are reliant on groundwater. The 2000 census is not very reliable. It's kind of shown to be not reliable in a lot of areas. So we had to interpolate between, I think, 1990 and 2010. And based on that, we didn't see a huge change in population. Might have gone up in some areas and down in other areas. And so we made the assumption, and also because it's a pretty small amount of water relative to the total water budget, that that population was going to be stable going forward, which we felt was reasonable and difficult to predict as well. So that's another kind of underlying assumption in our predictive scenarios, but just kind of looking at how much water we're talking about compared to agriculture or outdoor domestic watering. It's pretty small, so we felt comfortable with that.
Okay, thank you.
Mm-hmm.
We do have a couple of comments in the chat window. I believe this one was already answered, but I'll go ahead and read it. Sarah commented, "You're using rates from someone who isn't using meters to measure water usage. I believe you mentioned that you looked at other sources and it was a common rate for frost protection. I'd like to see a corroborated professional source for the application rate."
Sure, yeah, I can share that again, yeah.
And then there's a comment from Bethany. "The model memo says that you are using the CDEC data for Kelsey Creek. Is that a typo? I thought we were using the QAQC WDL data."
Oh, yeah, I think it's whatever is the QAQC data. That might have been a typo.
And then the last comment from Sarah is, "To confirm, did you say that the surface water diversions were less than 100,000 or 1,000 acre feet a year? Did you look at each creek and big valley?" And this was based on the State Water Resources Control Board data.
Yeah, so that's from ERIM's Electronic Water Rights Information Management System. So every diverter is supposed to submit their diversion amount, monthly diversion amounts, to the State Water Resources Control Board. And so we got that data from that database. I think it's important to recognize that there are some errors in those data, and then also there are diverters who do not report their diversion. either a illegal diversion or they're misreporting what they actually diverted. And so that's a huge source of uncertainty, especially during the model calibration period, because you're assuming what's reported to the water board is your diversion amount, but it could be different to a certain extent. And it's kind of unclear what that is, but it is definitely a source of uncertainty, but not really something we're able to address without better data at this point.
So at the moment, there's no more questions. So is there anyone else with any more questions or comments that they want to ask Eddie or Nick at the moment?
I was going to just say something real quick on the modeling side, and I kind of mentioned this at the GSPAC meeting a few weeks back, but the model itself, is being utilized to develop the water budgets, which are required as part of the GSP regulations. The sort of sustainability elements, really, we're utilizing sort of the RMS wells, the MTs, the MOs. And so I just want folks to recognize that these models are a tool. They're useful in the concepts that some of the concepts that Nick sort of explained today, and then also the idea of sort of that stream flow enhancement type project. So it's a tool that we can utilize, but recognizing there are errors in it. And as we kind of move forward with sort of GSP implementation, we need to sort of as a group try to figure out how do we make this become a better tool. And so touching on some of the elements that Sarah brought up, like, hey, this frost protection piece, how do we come up with sort of better estimates? I mean, that's something that I think we all recognize we need to do. Also trying to really understand the surface water, groundwater depletion piece, recognizing we need a better monitoring network. So I think those are things that we need to kind of better this tool. So it's not finished. It's never really finished, but we're going to build on this as we kind of move into the future. So I just kind of wanted to mention that to folks. So that's me on my soapbox. So sorry. I guess another question with this group specifically was, and again, recognizing we're doing this in other basins, and so they're also having some similar sort of challenges, is there an interest in perhaps keeping this group together and meeting quarterly so we can start to share ideas, share information, if we start to identify potential resources where we can fill some of these data gaps, we can kind of capitalize on that and move that forward. Is that something that this group would be interested in doing? And if so, is quarterly enough? Is there others we want to bring in, on board? Those are kind of questions that, maybe we don't need an answer today, but please, let us know. It's not like this is going to end, once the GSP gets submitted. It's going to be sort of this ongoing sort of dynamic process for a while. So. Hopefully the silence doesn't mean you don't ever want to see us again. But anyway, I think there's errors, and we need to look at ways to sort of help address some of that, reduce that uncertainty. I think is really, really important. So
I think the group should keep meeting, given kind of data gaps in the model as we move forward and try to fill some of those. I'd be in favor of that.
Right. And also there's a lot of money coming down the pipe, no pun intended, to sort of support local projects, sort of increasing our monitoring network. We're working with DWR right now, and I don't know what the final number is going to be, William, but we're thinking at least 2 or 3, nested wells, maybe the 100-foot to 300-foot range. And then also we're going to try to put some wells close to Adobe Creek and Kelsey Creek, if we can get the right land sort of agreements in place to sort of really try to better characterize and understand that sort of depletion piece. So, and your input on that is really important. And again, if the resources are there being provided by the state, if we don't capitalize on them, somebody else will. So just kind of keeping that in mind. So.
This is Peter. I would support that. I think that's a good idea. It's important to understand what that relationship is between pumping somewhere in the vicinity of the creeks and creek flow.
Right. So I don't know, we've got about 12 minutes. I don't know if folks, have any other questions, concerns, ideas, please let us know or follow up with us at some point. We'll maybe give it another minute or so, Marina, and then if nobody chimes in, I guess we can, get out a little bit early. Which wasn't always the case, but.
This is Peter again. Quick question. These slides will be on the website, or are they now? And
I'll try and put them on the website tomorrow. So all the slides will be on the website from both the financial ad hoc meeting this morning that we had at 10, and then the slides from this meeting. I'll try and get them up tomorrow.
That'd be helpful. I'd like to be able to go back and study the slides relative to precipitation, frost protection, and so forth.
Yeah, I've noticed in the past that when I've looked for slides on the website, the slides that are given by Eddie and folks are not necessarily included in the presentation. So I just want to make sure that, these are going to be up there.
Bethany, if you'd let me know which ones are not, because from my understanding, the website is up to date on all of the slides and videos, agendas and minutes, other than the 2 meetings that we just had today.
Yeah, when I've gone back and tried to look before to review some of this stuff, it's as if the main slides from the Lake County group are up, but anybody who showed their slides as like a sub-consultant were not up there. So I'm not going to go back and find out which ones they are, but
yeah,
I want to make sure these go up so I can look at them.
Bethany, this is Christy. I think that there was an original set that we had done the decks separately, and then they were combined together and put back up. So I know that there was one historically that when we really first started that happened, but then they got combined, and then we've tried really hard to make sure that they get combined as one deck, just because it's easier for like Sky to access them and that kind of thing. But if you do run into that, let us know. I think we rectified that one. I do remember there was an issue with that.
Thank you.
Okay, so shall we wrap it up, Christy? What's your thoughts, Marina? Should we end it?
Yeah, I'm not seeing anyone jumping up out of their seats or poking their webcam for any other questions or comments. So thank you, everyone. Yes, we will have these slides and this recording up on the website by tomorrow. And we'll send everyone in the listserv just an email, because I know we had 2 discussions today that folks are patiently waiting on those recordings and those slides. So we'll send an email by tomorrow to let folks know that that's up there. But other than that, just another shameless plug that comments are due tomorrow. We're still looking for comments for our draft GSP document. Please feel free to share the word, but thank you everyone for joining us. And thank you, Eddie and Nick and everyone for your presentation today.